All right, let's look at the complex plane. All right, this is a good way to visualize what the complex number looks like. All right, so let's say z, complex number z, let's say can be written as a real part plus bi. So b is the imaginary part. All right. So you can see that we can find the corresponding point using a as the x coordinate and a b as the y coordinate. Say you can have a here and the b might be right there. Right? Then we can locate a point. So by going here, all right. So we can locate a point right there. So this represents a plus bi. So if you write it as an ordered pair, so we can write it as a comma b. Right? Once you introduce xy plane or complex plane, then it's natural to talk about also polar coordinates. So if you draw a straight line from the origin to the point, right, then let's say angle is going to be theta there, then the length is going to be r. Right? So we can, in polar coordinates, this same point can be written as r comma theta. Right? The conversion between a comma b and r comma theta would be, right? So we know that the a can be found by, let's see, to find a, which is right here, right? So we can multiply r by cosine of theta. So a is identical to r cosine of theta. And b is going to be r sine of theta. Right? Then we can talk about the original z. Right? So since z is a plus bi, so this is the same thing as r cosine of theta plus r sine of theta I. Right? So since r is in common, I'm going to pull out r. And then you have a cosine of theta plus I sine of theta. Right? You can see that we found something very familiar. Cosine of theta plus I sine of theta can be rewritten as e to the I theta using the Euler's formula. So here's the Euler's formula. Alright, so we can rewrite this guy r. So r is already there. This guy by Euler's formula, e to the I theta. Right? So there's an exponential expression for z, which is r e to the I theta. Right? So you can write it, rectangular coordinate system, or you can use polar coordinates, or also you can write it in exponential expression. Right? So this is called complex plane. It's a great tool to visualize, complex numbers. Right? That's it. I hope that this was clear.